Hello, everybody, and welcome to our webinar. Some very quick introductions. Today, Christian Chanel will be delivering a presentation on ethylene steam cracking furnace efficiency. The presentation will take about half an hour. There will be a few slides and 2 videos. And then after the presentation, he'll be taking questions. Christian has worked in the industry for many, many years. He's very experienced. So if you have any questions related to the content or anything else related to ethylene and furnace efficiency, please don't hesitate to ask. I will now pass this over to Christian and we can start.
Hey, good morning, everyone, or good afternoon, good evening, wherever you are in the world. Thank you for the introduction, Marina. So I'll run through this. So this will be specifically, it's our ROV convection cleaning system, and we'll show some examples and case studies then from specifically relating to ethylene furnaces. So without further ado, I shall move to the next slide. So as you are all aware, to achieve the correct cracking of hydrocarbons, ethylene furnaces must maintain a temperature between 1470 and 1600 degrees Fahrenheit on average. Some can be higher than this, as we know. So there's a very narrow band of temperature that's actually required to successfully create the product. The convection section is a vital preheat mechanism in the ethylene furnaces. So that helps to make sure that the product is just the right heat before it heads into the radiant section, which then it travels through in potentially sometimes like a millisecond, very fast due to that small window. If it's too cold, excessive coke can form, and if it's too hot, then the product doesn't actually produce itself correctly. If you have fouling in that convection section, you have to actually you have to fire a lot more, so that increases the heat input. That can increase your stack temperature. A lot more fuel is consumed. There's a lot of heat stress on the tubes, can cause uneven expansion and distribution. That can actually lead to failures. A lot more running costs. And of course, on top of that, of course, if it gets to the point where you have to reduce throughput, then that really starts to hurt the pocket. Traditional methods of cleaning, and these consist generally of chemical cleaning or dry ice cleaning. Dry ice cleaning can have a part to play on online cleaning, but it's only very effective to get kind of 30%, 40% tops of the surface area of the convection bank. The problem with that, it doesn't actually achieve the results you want, but it can pull you back some performance to get through to the next turnaround when you can do a proper clean. The problem with it is the size of the nozzle. You can't get into the central rows. Another traditional method of cleaning would be chemical cleaning, and the problem with that, you can't guarantee where the chemicals are going to get to. And often we don't recommend chemical cleaning in any circumstances of heat transfer equipment, because we find that it can actually compound the problem you have. It can react with the fouling and cause you more of an issue than you had in the first place. So TubeTech convection bank cleaning, we have a system where we guarantee 90 to 95% plus of the fouling will be removed. This undoes everything that the fouling does. So it restores your, lowers your stack temperature, restores your thermal efficiency, can extend the asset life, reduce that stack temperature, regain lost throughput. And the big key to it is safety. There's no man entry. So what we take from you is the tube dimensions, fin height, horizontal, vertical tube spaces, tube supports with the height and details, any existing access that's there that allow us to put the ROV in. That access, if it's not there, we can also create that access. So this shows how the system works. This is basically talking you through what I've just described. You can find that up to a lot of debris can come in through the burners. They allow 1 part per million of debris to come through the burners. That settles out in the convection bank. Generally, it sticks in the fins in the coil. This bakes in and creates a key, which very quickly allows the furnace, the debris in the furnace to build up. and that starts to affect the heat transfer coefficient quite quickly. Different types of fouling we see, typically it can be refractory dust from downstream, which has sifted up through and got stuck in the process. We also see harvesting dust in areas of agricultural areas, for example, especially on a lot of the fertilizer plants, which are out in the country, as it were. In a desert location, sand makes up a lot of that debris, and that can get stuck in there, and all of it leads to a negative effect on your heat transfer coefficient. This is just explaining the traditional methods which I described earlier. So the chemicals can compound the fouling. Also, if the temperatures are very high, then of course that you lead the risk that a lot of the debris is actually inert in the first place. So no chemicals can affect that. We do have some other good videos as well. One of them shows the new ROV, which is about to be released, which we're very excited about. Now we'll have an animation of how it sits on the tubes and deploys. So this is the information we take from you, those drawings there, showing the cross sections, and that all gets fed into the computer program for the ROV. And that allows us to devise the cleaning plan, lance angles, cleaning runs, etc., to make sure we can give you the most efficient clean there is. So the ROV actually goes in, as you can see here, it sits on top of the convection coils. It deploys its lance right down through the coils, so you achieve 360-degree surface area cleaning of all the coils, all the tubes within the coil. We're using very low volumes of water here, just typically 2 to 3 gallons per minute on that lance. This is where we get 90% clean. You can see the cleaning lanes we run. The impetus of that jet is very small as well, typically 2 to 3 inches. So there's no danger of any damage to any refractory. You see some examples of the ROV in action. Typically, we get, if there's no other issues within the process, we can bring the unit back to design operating parameters. Here's some before and after examples here. If you look at the top left, you can see that's the shock tubes on a unit. They very rarely get fouled because typically it needs the fins or studs for the debris to collect and cause the issue. But here they've had a major event, and you can actually see there's bridging between the tubes. So there's zero flow through that unit. Just to the right of that, you can see the results after we've cleaned with the ROV. And third from the left on the top row there, you can see the sulfur deposit on the tubes, and take it across to the next one. We've got that back to bare metal. Bottom left, you can see the studded. You can't see the studs. That's the key. There's so much fouling there, you can barely make out the studs. After we've cleaned with our ROV, there's the studs back there, and we actually got that unit back to design operating parameters as well. Then the last two here, you can see on the third from the left on the bottom row, we've cleaned part the way down. Then on the right, we've continued the cleaning down past that point. So why IGS Tube Tech? Well, we'll reduce those fuel running costs for you. That gives you a fast return on investment, regain lost throughput. And if you're suffering with that, then we can very quickly pull that back, and the return on investment is very fast. We're improving your asset life, getting rid of 95% of the fouling. Reducing CO2 and NOx emissions. Emissions is a big buzzword at the moment, and also reduces the stack temperature of the unit if you're suffering from elevated stack temperatures. Just a couple of examples here. I think we've got 3 case studies I'm going to run through quickly. So this was in Sasol, South Africa. 10% capacity increase. That's a little bit misleading. We actually regained the 10% capacity they'd lost due to the fouling. They'd had to reduce their throughput. Also gave a 12% fuel saving and a 10 to 20% stack temperature decrease across the 5 units we do. This actually is a good little diagram. It shows a typical example of containment which can be put in under the convection bank. This consists of some visqueen sheets here. We have some scaffold planks running along here which are clamped against the walls using these acro bars. That's one example. A lot of our clients have different ways of doing it. In this particular case study, they actually regained just over 1 ton per hour per furnace of production. Over the 5 furnaces at $770 per ton was the price at the time of the ethylene. They recouped over $25 million per year in the first year. And this is an interesting case study. So over the last 6 years in operation, their stack temperature had risen from 190 to 230 degrees Celsius. So that's a 2% loss in fuel efficiency. The furnace had no access points for cleaning at the time either. Some of these furnaces do have access and we find some don't, but we have the capability to make those access points, and it will create a door which is usable in the future as well for cleaning. We can actually do that online as well. So if you don't want to extend your turnaround to put these doorways in, we can do that whilst the furnace is still running, providing it's a negative pressure inside. So the purpose of the project, we needed to reinstate the overall fuel efficiency of that unit, try and bring their fuel usage down, reduce their emissions, and we had to create the openings for the ROV to be entered. So new access was created in between the coils where we can get to. You can see the red arrows there, where the spaces are between the convection banks, and the radiant section was isolated with a with a containment system which collected any debris and water that came down. That was then brought to ground level and put in a frac tank of some kind. So the ROV system, we removed 90% of the fouling from the convection bundles. No refractory was damaged. The ROVs are pre-programmed to direct the medium at the tubes only. And if you do have, castable and block refractory isn't an issue when you're cleaning this. If it gets a little damp and wet, we don't see any direct impingement of the water. It's like an overspray, so you get maybe a damp mist on there, which isn't a problem. Ceramic fiber can be more of an issue, but we do have the ability to write a very detailed control program which can maintain the jet's direction, the water direction away from the ceramic fiber. So the results in this case, as you can see on this graph, the stack temperatures before cleaning up at 240, 250 degrees, some peaks there. That's the turnaround when it was shut down. Then after cleaning, we brought this down to, by 40 degrees Celsius, which is quite a significant drop. So that brings a 2% increase in overall fuel efficiency from 89.5 to 91.5 on average. That's a 2 megawatt fewer combustion losses to the stack. And the plant has reported a payback period of less than 4 months. So 2 years after this project, they had a slight stack temperature increase again of 10 degrees C and a stable efficiency increase of 1.5%. So to make the benefits longer, so we can actually do something here to stop the ceramic fibers coming through and fouling the unit. We can encapsulate those with a ceramic coating, and we would use in ethylene furnaces in particular and neutral emissivity coating, so there's no issues with the steam production and the convection section preheat. And that basically encapsulates the ceramic fiber and stops it coming off the wall, and that can give you a long-term benefit on preventing the fouling coming through. Now, sometimes we know the fouling isn't all ceramic fiber and not all units suffer from it, but as that ceramic fiber gets older, becomes friable, you can basically grind it like a little bit of sand in your hand, then that can break off and start to travel through the unit and stick in the convection section. So this will actually encapsulate that and prevent that from happening. So we have probably one of our best clients, actually. We do ROV cleaning in the United States on a major Gulf Coast facility, and we've done an awful lot of furnaces for them. I think we're just actually on site now doing probably about number 22 on that particular site, and we're also working on their other sites. And we've also completed a number of CTEC and HVTS projects at some of the other sites there as well. So this is one of their comments. Thank you for the great work cleaning the convection section. It's pulled from June to April. You were able to support it and complete the job ahead of schedule. Thanks for the flexibility, work, and most importantly, completing it safely. It's from the TXO contract operations administrator, and we get a lot of feedback like this across all our sites, not just this one. And we know for a fact that on this unit, and they've told us we can share it, that they regain about $3 million per furnace in efficiency costs in the first year of each furnace we actually clean. So this just runs through the solutions we have for ethylene furnaces. We have the furnace convection section cleaning system, the ROV you saw, where we get 95% plus cleaning. We have the furnace refractory encapsulation coating, which can stop that friable, diminished ceramic fiber being drawn through the unit. We can also do quench tower corrosion protection with our high velocity thermal spray. Now that is a corrosion and erosion protection system. So that will basically, it's a thermal spray equivalent to weld overlay, but it's much faster and about a lot cheaper as well. But the effects are just as good. And the great thing with our HVTS system, I'm sure we'll cover this in another webinar, is that there's no heat affected zone in there. So what we do, we can spray this on. It instantly arrests any corrosion or erosion and creates an alloy barrier between the surface of a vessel and any of the mechanisms going on inside. So that will then prevent that from continuing. We also have some other products and product lines we do for online services for all furnaces, including ethylene. We have a hot refractory repair service. So if you're suffering any hot spots on your unit, we can repair those hot spots without actually shutting the unit down. And I'm sure maybe we can set up another webinar which goes through some of those services in more detail. We have a hot access creation, as I touched on earlier, which we can create those openings for the cleaning without having to actually shut the furnace down. We have a Lance scope inspection camera. If you wanted to do some online visual inspection of your furnaces, this can go into a unit. It has a camera on the end, and it can withstand up to 2,700 degrees Fahrenheit. And will read, goes up to 30 feet long and can read a size 10 font from 100 feet. So that's another quite useful thing. We use that often in conjunction when we're doing the hot refractory repairs from the outside, so we can see what's happening inside. These may be things you're also interested in. This shows our global positioning and some of the clients we work for. And we've got a lot of references from these people. And if you specifically wanted to speak to some references before potentially employing our services, then we can certainly give you those to talk to. And a lot of people are happy to talk to you about that. So just a quick overview of IGS here, over 35 years experience, over 400 employees working in 56 countries. Our clients are top blue chip, oil, gas, petrochemical, pretty much everything. We have a big power side as well. And we've completed over 6,000 projects in that time. Okay, I think that's reached the end of the presentation, Marina. So do we want to go for some questions?
Yes, Christian. Thank you very much. Can you hear me now? better know. While Christian cannot hear me, I will just ask him. Yes, please. If you would like to look at the chat, read out the question, and then answer it. That will be helpful for people who will be watching the recording afterwards.
So unfortunately, we have a bit of a disconnect. I can't actually hear Marina, and I'm not quite sure why. So what I'll do, I'll run through some of these questions here. So we've got Al there. Do you only work in the USA? No, we work globally. We have offices and facilities all over the world, and we can perform the work. Oh, someone's already answered that. I apologize for that. Do you have any solutions for the inside of convection bank tubes? Yes, we do. So we can clean those as well. If you have a coked up unit, we can actually get in and clean those. We do have a system, depending on the size of the manifolds as well, where we can actually deliver the cleaning solution through, I say solution, our cleaning system through the manifold into the different tubes and run that through to clean out any coking you may have, any blockages you may have. We also employ that system for boiler tubes as well. So if you have your steam drum on the top, mud drum on the bottom, the connecting tubes, we can insert that through the mud drum and clean all those boiler tubes without any man entry. Anyone else have any other questions there? We have a lot of solutions for ethylene steam cracking furnaces and other, all furnaces in fact, and heat transfer equipment. How long does each project usually take? So that's an interesting question. It depends on the size of the project. So obviously the size of the unit, the ones we do at one of our regular clients are typically about 40, 50 feet long, maybe 5 or 6 coils, each say 8 tubes across by 8 deep. And that would typically take 4 to 5 shifts. And we would normally work around the clock in the US, especially, to get those projects down. So 4 or 5 shifts would be 2 to 2.5 days. But again, it does depend on the size. Okay, convection section of the furnace, very narrow construction. Have you ever faced any bottleneck for robotic cleaning action? Not yet. We have, what we've done, we have units which can go down. The smallest gap we tend to find is on a certain design of unit where they go down to about 5.5 inches in space between the coils. We can deal with that. So we can go down to that kind of, anything smaller than that, we can't get the ROV in, but it depends on the depth of the unit as well. So we'd need to evaluate your drawings, and we will find a way of modifying it and using maybe slightly different equipment for certain areas as well to get you that efficiency. Can air be used instead of water? It can, but it's not as effective. If there's any aversion to water, we use in very low volumes. We don't have any issues with it, but it is the most effective cleaning medium. What we find with air is it's only any good on a very, very light, dusty deposit, which would typically tend to blow out with the draft anyway. And all it really does is move it around. It's difficult to get it out. How do you estimate the percentage efficiency gain before the application? Yes, we can help calculate the return on investment. We can do a furnace evaluation and work out what we think we would need data off you. We need your design operating parameters, new operating parameters, and your current operating parameters, and we can figure out what the main issues are. And we can do an evaluation not just on the convection bank. This is just how we can actually make your furnace more efficient and help you calculate that return on investment as well. How many months should you be involved before the turnaround? We like as much notice as possible, of course, but we can react very quick. We have an emergency response kind of mentality. So we have a case at the moment in Louisiana where they're asking, they've opened a unit up and it's really badly fouled, and they're asking us to be there next week potentially. So we can react very quickly as long as we have the resources, and we have enough employees to try and cover that. So we can react to emergency situations as well. But if we can have as much notice as possible, that is helpful. In cases where manual lancing is possible, do you expect benefits in terms of speed, cost, quality by using the ROV? Manual lancing, so it's very difficult to get into all the unit with manual lances, is what we find. Speed-wise, potentially it's not as fast with the ROV. Quality is going to be better because you're going to be able to get to the undersides of the tubes. You're going to get 90-95% coverage. Manual lancing, you're kind of hoping it goes in there. If you've got tight tubes, you're not going to be able to get that lance through the gap, which can be down to as little as 1/4 of an inch sometimes. The quality will be better, but the main key, of course, is safety. So there's no man entry. The ROV goes in and does the work. You don't have to physically have anyone in the box, anyone holding a lance. A lot of benefits, and we'd love to show them to you. So there's the system there. It's a different system. It's quite small. It's very technologically advanced. And on here, we actually have twin lances there to speed up the quality and the actual cleaning time. So you can see how the lance deploys right down into the coils. And here we have a forward-facing and a rotary. So the rotary ensures you're getting all the debris out from between the fins on the undersides of the tubes, which is something specifically with manual lancing you would struggle to do. This unit can actually change across from one tube to the next as well, without any intervention, which is extremely helpful. This animation is great, actually. It just shows how the fouling is being reduced. And that's the latest ROV, which is about to be released. It's completed field trials and is ready to go. The unit also has cameras on it as well, so you can see around, and we can prove the cleaning we've done so that the operator can see it. We'd be happy to talk about your particular concerns and particular issues and furnaces and any other challenges you may have in that or other heat transfer equipment, in fact.
Thank you, Christian. So I just want to thank you for delivering a great presentation. If anybody has any more questions, you're welcome to reach us on the email that I'm just typing in the chat, and we will forward your request to your local subject matter expert. As we mentioned earlier, as we just released in the new system, we will be talking about it in more detail during another webinar. And we hope you all have an amazing day and a great rest of your week. And if you have any reliability or efficiency issues that IGS can help you with, please don't hesitate to reach out. Thank you. Thank you, Christian.